So, welcome to this presentation on GWT programming with Xtend. My name is Sven. I'm the project lead of the Eclipse Xtend project. Well, I talk about this in the session. I have with me Anton. Do you want to introduce yourself?
My name is Anton. I'm Xtend and Xtend committer. So I'm working together with Sven.
Yeah, so we are from northern Germany. I mean, you are from Moscow originally.
I'm from Russia, okay.
But we are based in northern Germany, and there are 8 of us working on this programming language we want to show you today. We are not only working on that, but also on something called Eclipse Xtext. Has anybody heard of that? Okay, a couple of, like 50% or so. Eclipse Xtext is an Eclipse project. And it is a project that makes developing languages much easier than you would usually think. So programming languages, small configuration languages, whatever. Think of it as a parser generator that also generates an IDE or something like that. So with that thing, we've built a JVM language, and that is called Xtend. And it's not just a kind of playground or something, so we keep it very seriously and we like it very much. We do all the programming nowadays with Xtend instead of Java. So why did we do that? First, of course, we could, no. So the thing is, with Java, there's so much cool stuff. I mean, you all decided to take Java over JavaScript at some point because you used GWT. I mean, there's a lot of reasons not to use JavaScript, I guess. Java is cool because it has tools and so on, right? I mean, the whole ecosystem is nice, the tools are nice, it's statically typed and so on. The only thing that annoyed me is that it's so verbose and so explicit with everything. You have to tell the compiler over and over again what the types are that you're working with. You've put semicolons and be explicit about everything. And so we usually call this boilerplate, right? We have some abstraction in mind, and we need to like massage Java such that this abstraction comes to life somehow. So why didn't I just use Scala, for instance? The tool support was super bad when I tried it. That is the main reason, maybe. So Xtend is designed around 3 core ideas. The first thing is Java interoperability. So it's not meant to be a whole new language, including the whole ecosystem. Like, if you create a programming language, a serious one, that's a big thing. It's not only writing the compiler, but you need to grow a community, you need to grow an ecosystem with tools and frameworks and so on. That was not the goal with Xtend. Xtend is designed such that it really nicely integrates with Java. We looked, for instance, at items, Java items, typical items, like getters and setters and so on, and built in first-class support in Xtend. So if you will, the interoperability with Java is even better with Xtend than with Java itself. So all the Java APIs, they look much nicer, and you will see that with GWT today. We wanted to have a low signal-to-noise ratio, so type less and, even more important, read less to get really what the code is. So it should be clean and simple, right? And you don't want to pollute it with useless characters and stuff. And it should have some concepts that Java is missing. So how did we do these 3 things? The Java interoperability topic, the first thing we did is we didn't try to invent yet another totally strange syntax, but we wanted to use the familiarity of Java such that Java developers get up to speed very, very quickly. So it's a matter of a couple of hours to get to speed with Xtend. Then that's an important decision, very different to other JVM languages. We don't compile to bytecode directly, but Xtend compiles to readable Java source code. That makes it very transparent what happens under the hood. That makes, for instance, GWT work. it's just that. And it also allows you to opt out at some point if you think like, well, it was nice, but this or that didn't work so well, or so. That won't happen, but in theory, you can do that. It uses a JDK as a library. So that's one big part of a language is the library, right? I mean, getting a really good library, that's really hard. And so we didn't want to do that because there is good libraries, and as Xtend is designed to work well with Java libraries, we could just use the JDK. So when you write Xtend code, you don't have your own collections which need to be auto-converted to Java util list when you call out to Java or something like that. It's all just Java plus Guava. Guava just because it's a well-written API, I mean library. And it has some cool higher order functions like filter and so on. We didn't change anything with the type system. So Xtend is statically typed, and it supports full generics, primitives, arrays, whatsoever, with all the gotchas you know from Java and everything else. The main difference is that you don't have to write the types down so much because it has type inference. And because we didn't change anything, there is no interoperability surprises whatsoever, right? With other JVM languages that have like introduced, for instance, Groovy has dynamic method resolution. So overload resolution happens at runtime based on the runtime types. That's surprising at times, so, because it's different. And then, yeah, we focused on tools. So we've developed first-class Eclipse plugin together with that, and we are also working on IntelliJ plugin. Who's using IntelliJ? All right, so it's coming soon. We will have a beta out in March, so around March. Currently, the Eclipse tool is really, really advanced already. So that's really important for us, and we designed the language together with the tool. And also, we make sure that existing Java tools work nicely with Xtend out of the box. So low signal to noise. Type inference, I already mentioned that. That means the compiler can figure out what the types is. If you look at Xtend code, it looks like it would be a dynamically typed language because there's so little type information. Basically, the parameter types, that's it. But it's not. It's statically typed, and the IDE knows everything. It will provide you with content assist, proper content assist, and error checks, and so on. The type inference is even a bit smarter than the Scala one as a side note, so it really can do forward-looking and so on. There's property access, getters and setters. We do that a lot in Java, so there's first-class support to use assignments, for instance, to call setters. Very good defaults. We revisited the defaults used in Java. So for instance, visibility in a class, that's a protected, what is a protected package, the default visibility in Java. Something you use rarely. Usually a class is public, so that's the default. If you want to have something else, then you can specify it. But yeah, using better defaults. The advantage we had over Java is that we could look at like 15 years of Java and see how people used it and see the items, right? That wasn't possible in the first beginning when they designed Java. Sweet lambdas. The lambda expressions are, they work similar to Java 8, such that there is no function types, but if you have a functional interface, that is an interface with one abstract method, it will like use that. But the syntax is much more concise as everywhere with Xtend. Optional parentheses, optional semicolons, and then there's other stuff you can use to sugar your code and really make it dense. And then there are some powerful concepts we will see later in demos. That is macros, so the code generation step from Xtend to Java. That's not locked up, but there is a way to hook in. Then there's extension methods. That's a way to have methods which live somewhere else, projecting on an existing type. So that's, for instance, how we put higher order functions like map and reduce and filter and so on Java util_list. So they will be directly on list through extension methods. There's an enhanced switch statement that is similar to pattern matching. Template expressions for multi-line strings, very nice feature there. Operator overloading and dispatch methods. Dispatch methods are what I mentioned with Groovy, that is runtime overload resolution. Sometimes it's what you want, and in Xtend you can use the dispatch keyword and you get it. All right, so enough of talk in here. This talk is spread mostly in 2 demos. The first demo, Anton will give the first demo that's about Xtend and basic, and the second demo will be about a GWT application we've developed with Xtend. And if you have questions, raise your hand, because it's nicer to answer them right away rather than at the end. Like, yeah. So it depends. The question was whether final is the default. It depends. For methods, it's not the default. For classes, it's not the default. It's the default for parameters. Actually, for parameters, there's no other way. It's always final. You cannot make them changeable. And variables, there is val and var, like in Scala, and it's, yeah, we suggest to use val whenever possible. That is final. Anton will show that.
Yeah, okay. So I just want to show you basic features of Xtend and how it's nicely integrated with Eclipse. So it's already Xtend class, but it shouldn't be hard for you as Java developers to understand it. Only one difference which you can spot is just, or two, actually two, that to declare the methods, you should use def keywords. And to declare the variable, you should use valor or var, depending on do you want to have constant variable or you want to reassign it later. So as Sven told us that Xtend is generated to Java, and under your project you could find so-called Xtend gen folder and its output folders for Xtend. So Java code will be generated to this folder, and you could find it here. Also, you could navigate to generated Java code only when you really need it. Usually you don't need it from editor, so you just select some code here, and then you can call open generated file, and it will navigate you to Java code. And from derived Java classes, you can go back to source classes, which declared in Xtend by means of open source action. So we don't need to be so ceremonial with Xtend as with Java. As Sven said, we have very good defaults. All types are public. You could remove it here. Methods are public, and fields are private. Then here we have new array list, which creates a list of person. And you can notice that we don't change this list later on, so we don't add new values. So to create a mutable list in Xtend, we have a special so-called list literal. And the syntax for it is hashtag and then square brackets, and then you can list your values inside square brackets. Also, Xtend comes with type inference, so you should not declare types over the place. For example, here it's obvious that person is of type list of person, so we could remove it. We could remove it for greeter and for person also. And return type of methods also could be derived. So in Xtend, we don't support statements. Everything is expression. It could be put in expression context. So with for, it's not for statement, it's for expression. And in that case, it's the type of for is void. So return type of greet method also will be void. What we also could remove or leave out is semicolons. They are not necessary in Xtend, and parentheses. So here we have a class person, which is written in Java, and it has only one field, which is name and like getter and constructor. So we call this getter from here, and in Xtend, you could use so-called property notation for getters and setters. So instead of typing get name, you could use just name. And if you have setters, then you could use assignment like person.name equals Anton, for example. Okay. So I said that Xtend has really powerful integration with Eclipse. You saw that I could navigate to Java and to Xtend and back and forward. What if you want to debug Xtend code? So you will do exactly the same what you do with Java. You just put breakpoint, and then you call debug as Java application. And when debugger hits the breakpoint, it will stop and open debug perspective, which is not something new. It just always was there. And then you could observe your execution context. So here we have a person's variable. And you just use the same action. So you could step over, and you get new local variable person, and you could step into. And you can see that it seamlessly steps into Java class. So it's really nice integrated with Java. And if I step return, it will go back to Xtend. Also, if you, again, in doubt about Xtend behavior, you always can open Java code even during debugging. So here there is an action, show source Java, and it switched to Java debugging mode, and you can go back. You also could just debug Java code after switching. So it was like basic. Xtend is object-oriented language, but it supports functional concepts. So we provide Xtend with a tiny library of extension methods for collections and primitive types. For example, for collections, we have here a list of persons, and we can rewrite this for with our high-order functions. So if I look at which methods list has, you can see that it has like method filter and map. And in our case, we want to have for each. And for each actually has an argument, which is a lambda expression. So the syntax for lambdas is square brackets. And then you should list your arguments or parameters. In our case, it's person, pipe, and after pipe is body of lambda. So here we could do it println. Then we can just copy this string here. As Sven said, our lambdas they are really sweet. And for example, if I rename this parameter to it, then you can see that it has different color, similar to with or super local variables, and it means that it has some special meaning. And the meaning is that you can leave out it. So you could implicitly call method or access members of it. So here, instead of typing it.name, I can just use name. And if you hover over this part, you see here the sugared version, and it's actually called getName on it variable. The second thing about lambda is that you could leave out parameters declarations. So if you don't list them and you don't use pipe, then we will add arguments or parameters for lambda implicitly for you. Okay. So this for each is implemented by means of extension methods. And I just want to explain to you what the extension method is. So again, in person class, we have a factory method as person, which accepts string and create an instance of person. And if you think about this method as an extension method, it means that you can call as person method on any string. So here, for example, I have string Sven, and at the moment I can't call it. What I should do to be able to call, to add as person method to string type, it's add extension modifier to this import. So now you see that all strings has a method as person. And it's a really nice way to enhance some existing APIs which are otherwise are closed for you. So using extension methods, for example, we provide support of lambdas, and we don't need to change in any way existing collections. Okay. So it was enough about basic features. Did I forget something? No. And
okay.
No, I have something
have
else. Yes. So we have here a Java class. We find a variable, and it means that this class is immutable. But we're missing something here.
It's not.
It's not here. Okay.
I mean, it's immutable, but it lacks features for
lacks
proper
features,
data
like
value type.
hash code equals and toString. And what you usually do, you go here and like generate for me hash code and equals using name, and then generate toString method using name. So it produces a lot of boilerplate code. Also, with getters, it's some idiom of Java, and it's kind of boilerplate code as a constructor. We could overcome it in Xtend using so-called active annotations. So first what I will do, I will convert this class to Xtend, just by calling convert to Xtend. So I have my person class. Then I will get rid of all this boilerplate code, which I know it's interesting in. It doesn't have any meaning. Okay. And I will remove final here. So you see that now it doesn't have a constructor, and if I open outline view, it just has not final field name. And when I annotate this class as data, then you can see that now this field is final. And if so there is a toggle button to show Java view on your class. You see that all this method is here. So active annotation is a way like you can change existing model during transformation process from Xtend to Java by providing libraries. Sven will show you more a bit later. So yeah, do you have some question about these basic features? Okay. Yeah, go on. Yeah. Do you have? How do I add constructor? Yeah, so I have data active annotation. And for each active annotation, you can provide processor, which will be executed at the time when we transform Xtend code to Java. And in that processor, you have access to Java model, and you can change it. So you could like add new constructors, methods. You even can derive new types, or create new files, or access your file system, add validations, and so on. We will use active annotation a lot in our example.
Yeah.
You will see it. Okay. Any other questions? Okay.
Have you heard about Project Lombo?
Yes.
Yes.
Yeah, they try to do that with Java and jump through hold for that. Yeah, it's a bit similar. It's a similar idea. So there's another question.
Does this ask person method also work with 2 parameters?
Sure, but then the second parameter is the first argument of the method.
Yeah, for
so
example,
that like only the first parameter becomes the receiver for extension methods.
like we use for each extension method. And then the first argument is the list, and the second argument is lambda expression.
Yeah, you could do something. Let me play around. We don't have these fields. Doesn't matter. We'll get that returning person. So that's another way to use a. Where's the navigator there? We could say something like this. So we haven't shown operator overloading, right? And that's an operator overloading and extension combined. So I can add operators to existing types using extensions. I could also have operators for person, of course, if I want to do that. So, but with regular methods, the other arguments would come like as normal arguments. Yeah, Jonas?
So how does it know actually over there that it's a person?
What?
How does it know that it's a person, not a string now?
Well, it types ++, this one shadows the, so it's something you shouldn't do, right? Override plus for strings is bad. Don't do that. All right, but it, the explicit import shadows the implicit import. So we have implicit imports for string. Also, all the operators you see here. So this, for instance, is broken now. You see that? That was a bad thing to do. I confused you totally. All right, let's close it. Never seen, not recorded. So let's go a step further and see how these features can be applied in a GWT application. For that, we have re-implemented the to-do MVZ app. Anybody heard of that? Yeah, maybe. Let me show it nonetheless. What is it? GWT run? Mm-hmm. So for Xtend, as you see, there is Maven plugin, there is Gradle plugins, standalone builder. You can there's no dependency to the IDE, right? The IDE is really just a tool. So let me start it. There is it. I mean, adding another compilation step doesn't improve the turnaround times, but it's incremental. The Xtend compiler is incremental, so yeah, and it's quite fast. As I said, we use Xtend to implement Xtend and Xtext nowadays, and we have a very large code base. We have 50,000 unit tests running against the whole code base, and so it scales, right? It really works. Say hello. So that's a to-do. You probably have seen that. Say goodbye. Stuff you can do, and we did that already, and you can like change stuff. So that's a GWT application implemented with Xtend. It's mostly a client-side application. There is only one server thing that is storing the to-dos and loading them again. So if I do a refresh, then they are still there. That's the server-side part of it. So I don't like this kind of, I need to see the trees. All right. So let's have let's have a look at the domain model, the very complex domain model of the to-do app. That's to-do Pojo, right? It implements serializable, of course, because we want to send it to the server and back. We use GWT RPC, and we use another annotation, not data this time, because we want to have getters and setters. We don't want to have hash code equals and the like, so that's why we use accessors. There are some active annotations that just come with a standard library because they are so useful. That's data, accessors, delegate, something like that. But the real power comes when you implement your own annotations for specific frameworks or even your own kind of project. So that's what we did, for instance, for the to-do service impl. Here, that's the RPC implementation and declaration of all the needed interfaces and whatsoever. So we have a class, we define the methods we want to have, and we say add GWT service, and you see on the right-hand side here, I hope it's not too small, there is this class, right? But there's also the to-do service interface automatically derived and implemented. So if I do F4 here, open call hierarchy, you will see it's a proper call hierarchy for a GWT service, right? The IDE knows about that. There's no kind of like late magic going on and the IDE is broken all the time. The IDE knows exactly what's there all the time. Navigation works properly. So for instance, where do we use it here in the presenter? You see we use the to-do service async, right? If I go there, I end up here. And I think that's what you would expect. And also if you call a method like save, you end up on the save method. And you can even like have Java doc here, go here, hover, and it has the Java doc, right? So it's really nicely integrated, yeah.
So this is pretty magical in Eclipse. Would it be the same in IntelliJ when we have that?
Yeah, sure. It will be even better because it's IntelliJ. No, I mean, we all know IntelliJ sucks. No, we want to have this kind of seamless integration for whatever tools we support, and we also want to keep this quality for everything we release. So yeah. So let's have a look at the to-do presenter. Is there a question with GWT service stuff? It's pretty clear, I guess, right? Most of you have seen this expanded pattern in Java, written that, maintained that. So we have here entry point, to-do presenter. There's no annotation this time. It just it creates this to-do service async through the code generation of GWT. And then we override on module load. And here we initialize the to-do view. And so this one here is the with operator. It's just library. We overloaded that generically for objects and initializers on the right-hand side. So left-hand side is any object, any t. Right-hand side is a lambda that expects the t. And so you can create some object, and on the right-hand side, it's assigned to it, and you can initialize it. That's what we do here. We create a to-do view, and then we initialize it. And by using this with operator, you get a kind of nice tree kind of syntax, right? So these are all lambdas. So when we can hover over it and you see the declaration, well, hello. The declaration is really there. Add to do, it expects the lambda, and we initialize all the callbacks for the view here. So I guess that's the most important part to show here. The next thing I want to show is the to-do view. It is backed up by an XML file or HTML, but you know UI binding. And you know how that works, the UI binder stuff. You have this XML, and therein you have some UI field declaration stuff, and if you want to code against them, then you need to declare them in your class and do some other plumbing, and then you can access them and add handlers and so on. And this is, again, something that should be kept in sync, right? You don't want to have this duplicated or so. So what we do is we have this annotation that takes the name and looks like next to the source and picks up the UI XML, parses it, sees all the UI field declarations, and puts them automatically into your class. So all these fields you see here, they just come from the annotation. They are not declared directly. So this is not here. This is here. And you can even, like, if you change that and save, and you see it's immediately broken. So it really knows when there is something I've read from through compilation, it changes, I need to respin. And it's incremental. It's not like everything gets recompiled as soon as anything changes, but it's really proper change affection detection. So it really knows, I read this file and it has changed, so I need to recompile. So let's change that back, or I want to show you, like, the editor really also gives me this the thing. I haven't saved the right-hand side. That's why it's not, like, it's proposing the old stuff. If I save now, it's then broken again. All right. So, Any questions regarding the UI binder stuff? Yeah? Good question. What if I rename this variable? So rename refactoring in general works nicely with Xtend, but in this cases where you read it from stuff that is not covered really with ASTs, it doesn't work. But it will tell you, like, you cannot do that, right? So in that case, you should just do find and replace. Yeah, that's a limitation we want to work on. Okay, so then this view here, there is this section where we add the actual to-dos, the to-do panel here, and each element here is a so-called to-do composite. And this one is not backed up by XML, just because we wanted to show how you can program widgets in Xtend. And so we've created a builder API for the widgets. And so you can write UIs like this. So it's similar to XML with less kind of these brackets and this noise, and statically typed, including full like IDE support and so on. So I think that's a really nice thing to use as well. So both are nicely supported, the UI binder stuff as well as programmatic UIs. And these things we've shown, we somewhat created them to showcase GWT and Xtend. I mean, we have some experience, also some real-world experience with GWT programming. But they are all in a project at GitHub, so they are open source and they are meant to like be enhanced. So if you want to use them, feel free to add pull requests or file bugs and so on. And even like if you've understood the basic features that Xtend provides, I guess you have even better ideas how to overcome some boilerplate here and there. And as you might have found out by now, it's not GWT only, so you can do any kind of Java application with it. So that's the stuff we have so far here. There's a couple of annotations. I showed you already. The first one I didn't show. Anton, could you explain what client bundle is?
You know what a client bundles in GWT is. And you know, if you have CSS file and you want to access classes or constants from this CSS file in your Java class, then you should have an interface with proper methods. And like this annotation will keep in sync interface and CSS file. So it parses CSS files and it creates method for each constant and class name.
So similar to the UI binders thingy, but with GSS and CSS. GWT service, we saw that. JS native, JSON-I stuff. This is more interesting JSON-I stuff. Overlay type by example. I built that just yesterday, so forgive me if there's a bug. But let me show it because it's nice. I can do it here, I guess. So in Xtend, you can have any number of classes, top-level classes in a file. It's not so strict as Java. So I could just say, well, we have a person here. And I say add overlay type by example. And I need to put an example. And the example is, of course, JSON. So imagine you want to like call some REST service. You go on their website, and then they have this JSON example, right? And you want to work with that from Java. And so you can do all kinds of frameworks that exist. And so you could also use overlay type by example. So imagine one thing we didn't mention is strings can be like single quote or double quote, and it can be multi-line. So it comes in handy when you have a string full of double quotes and you just use single quotes, or the other way around. So name is Anton, and age is 27. And then we have you have pets, right?
Yeah, for sure. A couple.
I need to add comma here. There's comma and comma. So usually I would paste it. I don't have it in my. Is that the right syntax? So And the pet has also a name. And kitty. Okay. So you see, we have created class person using an example. I have not even saved, but the IDE knows already. It created me the proper getters. You see they are native and final. And it even created a nested class pet with the name. And it really applies to also the pattern you have if you use this JavaScript object overlay types. So let's see the generated code. So that's what is generated, right? It adds the JavaScript here in the comments and so on. All right. Questions? Okay. If you add, like, from where should it take the Java doc? All right, yeah, it doesn't do that, but I could. No problem. Yeah. Okay, another question?
I would like to start tomorrow on an existing project with Xtend.
Yeah.
Can I just write to the existing Java packages Xtend classes?
Yeah, we showed that in the beginning. It's just a Java project. Yeah, you live in Eclipse, I assume that? There is no thing like an Xtend project or Xtend perspective or this kind of thing. It's just Java and you add files there. And it will add this tiny library, which is on Maven Central. And it will need to have this extra source folder where it generates to. Usually that is hidden, so I use a dot naming scheme usually because you never need to see the generated code because the compiler is always right. No, but it's really, I mean, it's really, as I said, we have 50,000 unit tests and it's well tested. It works very well. Yeah, Jonas?
Just a comment to add to that. So, getting started with Xtend is pretty simple because you just add one class over there. But what I think is even more important is that getting rid of Xtend is just easy. So, I mean, this is really important.
Did you try?
Find something out, because you can easily decide, I'll try it out tomorrow. If it doesn't work out, then just say, compile, just give me the Java classes. So that sets the bar for actually starting with Xtend really well.
Yeah.
That's true. Like we had with Scala, we never could switch to Scala, even if we wanted, because once you start it with Scala, you cannot get rid of it.
Yeah, there's a lock-in.
Yes, that's any after that. So.
Yeah, also with this huge library and integration with existing frameworks and so on. Yeah. So we have a quick recap. I hand over to Anton then again, but maybe we not too much.
Yeah, we'll try to keep it really quick because we're short on time.
Let me start it for you.
From here, okay. So I will just recap basic features first. So just by using Xtend without powerful features, you already could improve readability of your code a lot. So we have here just Java code snippet of click handler which filter out a done task. And you need to spend some time reading it. And with Xtend, it's just 3 lines of code, and it's obvious at a glance what it does.
That's the difference, by the way, between there's obvious no defects in Java and there's I messed it up, sorry. You know that wording? There's no obvious defect and there's obviously no defects, so that's the difference.
Yes, there is no defects. Okay, for client-server communication, we use GWT RPC. And again, in Java, you know this pattern that you need server-side implementation, server-side interface, and then you need client-side equivalent, async equivalent. And you have these problems that you should keep it all in sync. And yeah, basically, in Xtend, we use GWT service active annotation to overcome the issue with boilerplate. But what I also like that it improves your user experience. You saw that if I select save method and say find references, then I will find all usages of async interface.
We didn't try the open call hierarchy, but I guess that will be seamless as well. So
yes, call hierarchy will show that you call from client side save method on server side.
Yeah.
For